Hello engineers, welcome to another video on low level design. In this video we're going to look at a very interesting pattern called the bridge pattern. I hope you're ready. Let's get started. So first let's start with the intent. So decouple an abstraction from its implementation so that the two can vary independently. So this definition does not make much sense until we understand the problem of class explosion, right? To understand class explosion, let's take a simple example of food. Okay, let's say we are a chef and we want to make dosas. Okay, the idea is to make different types of dosas, right? So dosas have, let's say, two dimensions for simplicity. The first dimension is type of cooking. And let's say there are two main types of cooking. One is on a pan where we fry a dosa batter, and then the second type is steam, where we don't use oil and we put steam as the type of cooking, right? So this is one dimension where we deal with type of cooking. And then we deal with type of toppings, which is basically type of dosas. Okay, so this is our second dimension. Here there can be a blast of options, right? There can be a plain dosa, there can be a masala dosa, there can be onion dosa, and there can be n number of combinations like this, right? And for each of the combination, I can do a pan plain dosa or a steam plain dosa, a pan masala dosa or a steam masala dosa, and so on, right? So if I have to derive classes for this is how it will look like. First, I will have a normal dosa class. Dosa class will be extended by pan dosa, and it will also be extended by steam dosa like this, right? So there is inheritance happening here. So this is one dimension, the type of cooking, right? There can be two types of cooking of a dosa. Now for each type, there can be multiple types of dosas possible. So there can be a plain pan dosa, there can be a plain there can be a pan masala dosa, there can be a pan fried onion dosa, and so on. And there can also be a plain steam dosa, there can also be a steam masala dosa, there can also be a steam onion dosa, and so on, right? So every time I'm trying to add a type of dosa, I have to add it to the main dimension. Either it is a pan dosa or a steam dosa, I need to add two more classes, right? And this is growing exponentially, right? So for every change in this dimension, there is a change in the lower dimension, right? So there are two independent dimensions, but they are somehow tightly coupled because of this approach, right? This is called class explosion. So the bridge pattern tries to solve this problem of class explosion. So how can we separate these two dimensions so that they can grow independently? So if I want to add a third type, let's say oven dosa, maybe. So I should be able to do that without having to affect the other dimension, right? I want to be able to expand each of these dimensions independently so that they can grow on their own without having to depend on each other. So the bridge pattern helps us to deal with this problem. So by using bridge pattern, we can do the same thing like this. So we have a dosa builder, let's say, which will take in the type of dosa as input. Okay. So this dosa builder will be extended by two builders, the pan builder, the pan fried dosa, and also the steam builder. Okay. Now this is extendable to any type of builders. So by taking in the type of dosa as input, we are using the composition relationship. Okay. So what is the composition? We are going to do a dosa type as another dimension independent of this one, and this dosa type can be implemented by any type of dosa. So this can be onion dosa, this can be masala dosa, this can also be plain dosa, and so on, right? And this is an interface. So by using the interface, we are able to create multiple types of dosas, right? That is one dimension which is building on its own, which can grow on its own or shrink on its own. And there is the other dimension called dosa builder, which will also grow on its own because there is nothing stopping me from adding a new type of dosa builder, right? I can add an oven builder here as well, right? So by changing the relationship from a multi-level inheritance to a composition plus inheritance type of relationship. So this is a hybrid of composition plus inheritance. So the builder pattern uses these two techniques to solve the problem of class explosion, right? So you can think of it using furniture example as well. So let's say you want to build different types of furniture. So the two dimensions can be the material. So there can be a wooden furniture or there can be metallic furniture. So this is one dimension. And the second dimension is the type of furniture, the chair, sofa, table, etc. Right? So I can make a chair using both a wood material and also a metallic chair, right? I can build a sofa with both wood and metal and so on, right? So both of these are independent dimensions, and by using the builder pattern, we can extend them or we can let them grow independently. So that's the whole idea behind the builder pattern, right? So this composition of using one dimension within the other, this is the bridge. That's why it is called a bridge pattern. Okay. Now let's try to see some examples from the software world, right? For example, we are building loggers. So loggers, one dimension can be the type of log. There can be a JSON log, there can be a text log, there can be a file log, and so on, right? And another dimension is the storage place. It can be stored on a file, it can be pushed to the console, it can be pushed to the cloud. There can be multiple storage places, right? So this is one dimension and this is another dimension. So we can use the bridge pattern to expand them independently, right? And similarly, database engines. This is what we'll code today. Let's say we have multiple database engines. For example, MySQL engine, and we have MongoDB engine, and we have, let's say, DynamoDB, VectorDB, and so on. There can be any number of engines, right? And each of them require different type of query builders. So query builders on the one side, there can be SQL query builder, there can be NoSQL query builder, there can be vector query builder, and so on, right? So the query builders is one dimension and the engines are the second dimension. So by using the bridge pattern, we can combine both of them so that they can grow independently of each other, right? So this is something we'll code today. So these are some of the example use cases of the bridge pattern. Okay. Now let's see how the bridge pattern is actually implemented using our UML diagrams. So let's go to UML now. So this is the class diagram implementation of the bridge pattern. So on one side, we have the dimension. This is dimension 1 and this is dimension 2, right? So in dimension 1, we can have that cooking method as an abstraction, right? So this can be one abstract method which deals with cooking method as one dimension. And this can be extended by, let's say, the steamer and the pan fried cooking methods, right? And on the other side, we have the dosa types. So there's a common interface for dosa type, and there can be plain dosa, masala dosa, and so on, right? And by using one of the object into the first dimension, by saving it in the first dimension, we can make use of the bridge pattern. So if there is an operation that needs to be performed, let's say cooking, so it can use the object from the second dimension and call the operation, right? So that's how we can use the bridge pattern. So if this is a little confusing, try to relate it with our dosa example. So this is the first way without the bridge pattern where we can see class explosion. And this is the second way where we can see the same class diagram pattern. We have dosa builder type as one of the dimension. We have pan builder, steam builder, and so on. And this is the second dimension where we have the dosa types, right? So it is the same implementation, just represented in a formal way. Okay. Now let's say the sequence diagram. So the client wants to deal in two dimensions. First dimension is concrete implementer A. So the client will create a concrete implementer object and take the instance. And while doing the second dimension, the client will pass the instance of the first dimension and take the instance back and call upon the operation on the second dimension. So when this dimension is called upon, the abstraction will call upon the concrete implementer and then use that response to return back to the client, right? The same thing is represented here as well. So if you observe it carefully, so there is an operation, right? And this operation is calling the implementer operation by using the implementer object, right? Because it is already composed within the class. So we have an implementer object within the abstraction, and when the operation needs to be called, it will make use of this object to call upon the operation, right? So that is how the sequence of this pattern goes. Now let's see the usage of this in databases. Like we discussed, there can be two dimensions. The first dimension is the database engine. There can be multiple database engine. There is MySQL engine, MongoDB engine. There can be an engine for DynamoDB. There can be an engine for VectorDB, and so on, right? There can be multiple database engines like this. And on the other side, we have query builders. So there can be different types of engines supporting different types of query builders. So MySQL engine will need a SQL query builder. MongoDB engine will need a NoSQL query builder, and so on, right? And if there is a Postgres engine, it will also need a SQL builder. And if there is a DynamoDB engine, it may also need the NoSQL builder, and so on. So these are two different dimensions and they can grow independently, right? So what do? In the query builder dimension, we will compose it with the engine. We will take the object of the engine and put it in the query builder class, right? So how do we do that? We can simply take it as input in the constructor. Okay, that's how we can do it. And once we have that object, we can give any methods for implementation, right? For example, connect, disconnect, execute, select, and where. This can be the common methods. And if any class wants to override it, they can override it. If any class wants to add more methods like joins for SQL queries, we can add more methods like this. And if NoSQL query builder is not happy with the select method in the original query builder, it can override and build on its own, right? So there is all kinds of flexibility here. So this dimension is not dependent on the engine, right? So that's how we can build the builder pattern for databases, right? And when we want to do the actual execution, so this execute method will use the object of the engine to call upon the execute query method, which is part of this interface, right? So that's how we can use the builder pattern. So let's see all this in code now. So I'm in VS Code now. We have the brits.cpp file. So let's talk about the first dimension, which is the database engine. So as you saw in the diagram, there is a common interface for database engine, which has connect, disconnect, and execute query methods. And this is implemented by MySQL engine and MongoDB engine, right? So they have their own implementations for connect, disconnect, and execute query. So this is one dimension which is growing independently. And then we have the second dimension called the query builder, which will have the database engine composed within it. So how does it do that? By using the constructor, right? So once we have that object in the constructor, we can use that to call upon execute query whenever it's required, right? And the remaining methods are just its own implementations. So there's a select method, there is a where method, from method, and so on. These are used for building the query. So here we can see the implementation of the builder pattern as well, because we are using the same object continuously to form method chaining, right? To support method chaining, right? So the query builder is extended by two things: SQL query builder, NoSQL query builder, right? And what is the SQL query builder doing? It has the DB engine object like before, and it has overridden or added a new method for join, because SQL queries need join as an additional feature. So SQL query builder has this additional method called join. And NoSQL query builder does not have additional methods, but it has overridden two of the methods, the select and where, because the select and where are slightly different from SQL methods, right? So in SQL we have the select query, select star from a table, and so on. But in NoSQL we have db.collection.find and so on, right? So there is a different pattern to the query. Both are query strings, but the syntax is different, right? So these are the two query builders. Now let's see the usage. First, we deal with the first dimension, which is database engine. So we have our engines ready. Now we create the query builders from the second dimension. We have the query builders ready. Now we can use the builders to compose each other, right? So for SQL Builder, we are passing in MySQL engine. For NoSQL Builder, we are passing Mongo engine, right? And because we have this, we can use method chaining now to call upon our methods. So SQL Builder.select from where execute. So within this execute, we can see the calling of the engine object to execute query method, right? Similarly, for NoSQL, we can use the select and execute or where and execute. So again, we can see the usage of method chaining using the builder pattern, right? So by using one dimension into the other, we are able to solve the problem of class explosion, right? So let's run this and see. Okay, like you can see, we have the SQL query example. MySQL is connecting to some hard-coded host, and then it is executing one query with where clause and another query with a different where clause and disconnected. Similarly, we can find the implementation for MongoDB querying as well, right? So this is the usage of the builder pattern. I hope it's clear now with all these examples. If you have any questions, definitely ask them in the comment below, right? So now let's see some pros and cons. So these are some of the trade-offs of using the bridge pattern, right? Firstly, we'll get a lot of extensibility because we have two dimensions expandable on their own, right? Extensible on their own. And then we get a great level of encapsulation because one dimension does not need to know about the other dimension's usage and so on. And then we get reduced class explosion, which is the main problem that this pattern is solving, right? And coming to the weaknesses, this can be overkill for simple applications. Like if you are able to reasonably manage the multi-level dependency, then no need to use this pattern. And the other reason is initial setup is very high, right? You need to understand really the dimensions and not fall into the trap of over complicating the design, right? So it needs careful planning, and initial setup is a bit high because we need to do dimension 1 setup, dimension 2 setup, and the composition needs to work together really well, right? So that's how we can use the bridge pattern. Okay, so in this video, guys, we have covered the intent, the example use cases, the diagrams, code walkthrough, and also some of the trade-offs. So if you have any questions or any inputs, definitely put them in the comment below. Thank you so much for watching. I will see you in the next one. Do subscribe to the channel if you haven't done already. Do leave a like if you found this video helpful. Thank you so much for watching. I will see you in the next one. Cheers.